Okay, well, happy Monday to you guys, and it's already February, so we are, I guess time is ticking on every day. We're getting older, I guess. And so what we'll cover today is we're going to look at some object-oriented programming systems in R, and in particular, we're going to look at S3. And credit to Hadley Wickham for kind of a lot of this material is taken from his textbook. Okay, so object-oriented programming, and we're just going to call it OOP from here on out, is a style of programming that focuses on defining different types of objects and functions that can be applied to those object types. And in R, there's actually several different systems of OOP. There's S3, which is going to be the subject of today's lecture. There's also S4, RC, and R6. And on Wednesday, we'll look at R6. S4 and RC also exist, and maybe I'll just kind of give them cursory mentions, but we'll primarily look at S3, okay? Hadley Wickham covers a lot of stuff on this topic, and he says S3 is the most important, and I would also have to agree there, okay? S3 and S4 and R are known as generic function OOP. There's also another kind of OOP called encapsulated OOP, and those are the RC and R6 systems. But all object-oriented programming systems store information in objects, and then actions or functions that can be done with objects are known as methods. All right, and I'll get into the difference between generic function and encapsulated OOP. So most other programming languages, so if you've taken a course in Python or C++ or Java or things like that, you would have been exposed to encapsulated OOP. All right, in encapsulated OOP, the methods belong to objects or classes. All right, and when you call a method, it's going to be something like object.method and then the arguments of the function. And the object itself encapsulates both the data pertaining to the object in the object's fields, but also the verbs or the behaviors that this object can do in the methods. So, for example, you can say this is a camera, right? This is technically a phone, but it can also be treated as a camera. And so we could say, okay, if this belongs to class camera, then it would contain information in the fields like how many pictures have been taken, how much memory is available, and things like that, other settings for the camera. And then the camera will have methods, basically verbs, of things that it can do, right? So you can say, a function that we need to give it is the ability to shoot a photo or to focus on a different portion of the picture, or maybe to record a video or to turn on the flash or things like that. So there's going to be different methods that the camera can do, right? And that's encapsulated OOP. R does have encapsulated OOP via the R6 package and also the RC reference class objects types. And most other languages only kind of implement an encapsulated OOP. However, R's primary object-oriented system is the S3 system, and the S3 system uses generic function OOP. In generic function OOP, the methods belong to generic functions. So objects or classes will store data in fields, but they don't keep the method information. So the methods belong to the function. They belong to the generic functions. The functions will look at the object class and behave differently based on the object, right? So, you can kind of think of this, in the English language, we have the verb shoot, okay? And the verb shoot takes on different meanings or behaviors based on the object you're talking about, right? So if you have a camera and I say shoot it, means you're going to take a picture with the camera, right? If I give you a hockey puck and I say shoot it, it means you're going to hit the hockey puck with a stick towards the goal. If there's a gun, shoot means to pull the trigger, to take aim and pull the trigger. If we say, the breeze, to shoot the breeze means to kind of chat idly. And so in generic function OOP, the function or the verb will behave differently based on kind of the object that it's associated with. And as far as computer languages go and are, a polymorphic function is a function that's going to behave differently based on different input types. Okay, and that's what R uses in its S3 and S4 object-oriented systems. It uses generic polymorphic functions. So so that's what we'll take a look at. Basically in base R, okay, in base R, when you just start up R Studio, it basically loads up just base R and the stats package and things like that. Everything's done via the S3 system. So it's going to be important to kind of learn this. So here's just kind of an example of when you've already used S3 generic functions without even maybe realizing it, right? So so here we have, there's a data set called diamonds, and there's different columns. One of the columns is the caret, which is a numeric column. It contains the size of the diamonds, which is a numeric value. And so if you ask the summary on a numeric vector, what it's going to do is it provides you numeric summary values, right? Like the mean of that numeric vector is 0.797. The median is this, the max value, the third quartile, first quartile, and the minimum value. So it contains, so when you ask for the summary on a numeric value, it gives you numeric summaries, okay? There's another column inside the diamonds data set, and it's a factor, it's an ordered factor, and it contains information, and so it categorizes how the quality of the cut, right? And so I don't know if you've ever gone diamond shopping, but a diamond can have an ideal cut, premium cut, very good, or good cut, and things like that. And so when you ask for the summary on a categorical variable, you can't compute the mean or the median or things like that, but you are able to kind of summarize it by just telling you, by tabulating them and giving you a count of how many of each category exists, right? And so this function summary behaves differently based on whether you give it a numeric vector or you give it a categorical or a factor, basically, okay? And so so that's a polymorphic function. It's the same call. You just say summary and then the vector you provide it, but it's going to behave differently based on what it is, right? And so other polymorphic functions that certainly you've used would be the print function and plot function as well as the summary function. All right. So far, so good. Let me give you your first quiz answer. First quiz answer for today is the letter D. D as in dog is the first quiz answer. D as in dog. So, so just some basic vocabulary is that the class is going to be the definition of a certain kind of an object, right? And classes will contain fields that are used to kind of hold information relevant to the class, okay? And then the other part that's important is the method. A method is an implementation of the function for a specific class. It's basically the verbs, the actions that can be applied to this class. So the class will define what the object is, and the methods describe what this object can then do. All right. Another idea is inheritance. Okay. So classes are often organized in some kind of hierarchy, And so if a method doesn't exist for the child, then the parents method is going to be used, right? And we would say that the child inherits behavior from the parent. Okay, so for example, you have an ordered factor, and an ordered factor inherits from a regular factor. So it's like the nominal versus ordinal variables, right? So nominal would be something like hair color. You've got black hair and brown hair and blonde hair and red hair and things like that. And there's no specific order as far as that goes. What's the order that hair colors should be displayed at, in the target aisle. There's no inherent ordering. I mean, maybe you can go from light to dark, but then, where do you put like gray and blue and purple and stuff? Like where did those go, right? Whereas ordered factors, like it makes sense to put them in order, right? Small, medium, large, extra large. Like it makes sense to arrange your clothing in a certain way at the store, right? Even though they're categorical variables. And a tibble would inherit from a data frame. So tibbles are kind of special versions of data frames that have these nice properties, but they inherit from a data frame. Okay. The process of figuring out which method to use for a given class is called method dispatch. Okay. And so, if I hand you something and I say, shoot it, your brain is going to look at the object and figure out like, what do I mean by the word shoot, right? So if I give you a basketball and I say, shoot it, you're going to look around the room for something that looks like a hoop, right? Either a trash can or a hoop or something. You're going to say, okay, he means to throw it towards this thing, right? If I give you something else and I say, shoot it, like if I give a camera and shoot it, you're going to say like, well, what should I take a picture of? And R, doesn't have a quote brain like we do, but it has a system for figuring out which version of this function, do I give you the numeric summary or do I tabulate the values into categories? And figuring out what it's supposed to do is called method dispatch. All right. And the way R does it is it looks at the object that it has received, looks at the class, and tries to find the correct function that applies to it. All right. Okay, so again, to go just cover a little bit more of what the different object-oriented systems are, we have S3, all right, and that is the system that's kind of most commonly used in R. Everything in base R is S3. Everything in the stats package, which calculates things like the standard deviation and linear models and stuff, that's all done in S3. S4 is similar to S3, but it formalizes it, okay? Because in S3, we're going to see that you can do a lot of stuff kind of on the fly in this ad hoc manner where you can kind of break systems. And S4 will kind of prevent you from doing that. It's a lot more strict and it has more rigid rules, but it behaves effectively in a similar fashion as S3 in that it's a generic function object-oriented system. And then you have RC, reference classes, which will do kind of this message passing or encapsulated object-oriented system. And along with R6, which is similar to reference classes, but is implemented with a library and is maybe a little bit more of an elegant implementation of encapsulated object-oriented stuff. Okay, so we're going to look at S3, and then on Wednesday we'll look at R6. Okay, base types are not an object-oriented system, but everything in the object-oriented system is built out of base types. Okay, base types in R are built out of C code. All right, so R is actually written with C code and Fortran, and it is kind of this language that statisticians built so they didn't have to worry about the C code. But the base types are built out of C code, and all the object-oriented stuff is built out of base types. So it's important that we understand the base types, right? So we've seen base types already. Those are your kind of atomic vectors and the lists. And you can always ask what is its base type by doing type of, and it will give you, type of just double or logical or integer and things like that, okay? Only the R core team can create new base types. And so we really only have the base types that we've learned about. There's a few more exotic ones. You've got functions and environments, but you also have things like names, calls, and promises, which sometimes you might see. Like if I don't know, if I do empty cars, I don't know, what is, okay, well, I don't know. Sometimes you might see, sometimes you'll see something called a promise appear in R without, but anyway, those are also counts as base types. But basically, anybody can create new packages and class types and stuff on R, but they won't be a base type. Okay. There's unfortunately, the naming of base types is a little bit inconsistent. Okay. And so if you ask for like the function mean is a function, but if you ask the type of, it's going to say it's a closure. The function sum is what's known as a primitive function, but if you ask for the type of, it comes back as a built-in. Okay. And so these are just kind of versions. So if I say mean, actually, yeah, this is a generic function, and sum is also a generic function, but it's going to be a primitive on the sum and things like that. So you've got different base types here, but the naming of it is a little strange. Okay. There is a function called is.object. Is.object will tell you if it's something, if it's not a pure base type, right? Okay, so so you don't ever have to write C code, okay? But S3 objects can be built out of any kind of base type. S4 objects use a special kind of base type. And then reference class objects are a combination of S4 along with environments. And that's kind of how R uses its object-oriented systems. And we'll also talk about R6. And basically, you can see if something is a pure base type, you can just call is.object, right? And if it's an object, it's not going to have a class attribute, right? So you can say, like, if X is just this vector 1 through 10, okay, this is not an object. We can do is object X, and that's going to be false, right? But if I say Y is a factor, okay, so Y is a factor here. Y is a factor is an S3 object type. Okay, so if I say class of Y, it's going to say it's a factor. Okay. Okay, so S3 is kind of the simplest object-oriented system in R. There unfortunately isn't a way to just directly test if an object is S3 in base R. You can ask is object, and that should return true if it's an S3 object. And then there's a function for is it an S4 object, and that should be false. So if it's an object but it's not S4, then it's basically an S3 object type, right? So here, if I say is S4 on Y, this is going to come back false. Okay, so a data frame is an object. It's an S3 object, and it's going to come back true. A data frame is not S4, it's an S3 object, so is S4 is going to come back false. Okay. We've already seen this. X is not an object, it's just an integer vector. And then recently they changed the default behavior of data frames. Data frames used to take strings and turn them into factors by default, but they no longer do that. Okay. So this used to say true, but this is going to just remain just as a string. But so, if I do this, data frame here, here's a data frame. df $x, this is not an object. df $y is not an object. Y being a factor over here where I created the factor on its own, that is an object, right? So is object on Y, that's true, is object df $y, that's going to be false. When we have generic functions in R, the generic functions are handle the method dispatch by using this function called useMethod. Okay, useMethod mean basically tells R this is a generic function. Okay, that there's no actual function all by itself that can do anything called mean. Okay, there's going to be versions of mean that will be able to do stuff. And so when we call the function mean, what it's going to do is it's going to look for a specific method, a specific version of the function mean that's going to be able to perform something for the object given it. Okay, so this is functional OOP. Functional OOP says the methods belong to the functions, right? This is different from other OOP systems, which where the methods belong to the classes. Here in functional OOP, the methods belong to the functions. And you can tell it's a generic function because if you ask for the definition of a function, and you can ask for the code that defines a function just by kind of typing it in without any parentheses, right? So normally when you type in a function, it's going to, tell you to put in some kind of object here, right? But if you call for the function without the parentheses, then it'll tell you the definition. And here we can see useMethod mean. So it's going to use, this is a generic function, and it's going to look for versions, methods related to mean. Okay, there's also internal generics, and we don't need to really get into that, but the internal generics are things like sum, bind columns, and the subset operator. But again, we won't really get into it, but they're known as internal generics. They're a little bit different in that they don't use kind of the other systems that exist. Okay. So basically, when R looks for a generic function, it's going to, or I'm sorry, a method that belongs to a generic function, it's going to look at the name of the generic dot the class of the object, right? So the mean function is a generic function, and we know it's a generic function because it says useMethod mean when we ask for the definition. And it's going to do things, it's going to behave differently based on the class of object you pass to it, right? So you have the class date, object of class date, and you can ask for the mean of a date object, right? So here I'm going to say x is going to be as.date, and I'm going to give it 2021, 01, January 2021, and 2021, December 31, okay? So what is the middle date of the year, the mean of the date, okay? So we can just ask mean of x, and this comes back and it says the mean of these two dates is July 2nd, 2021, okay? And again, when you ask for what is it doing, what it's doing is it's actually finding mean.date, and what mean.date does is it says it unclasses x, right? So again, x is a date, and we can ask what is the class of x, okay? And it's a date object, but you can say, well, get rid of the unclass x, and dates are actually stored as kind of these numeric values. And this is, I think, the number of days it is since, I want to say January 1st, 1970 is kind of like the 0 point on the computer, okay? It's an interesting thing that if you think about the way we use dates, right? February 1st, 2021, this is just an arbitrary, like we picked an arbitrary 0 point, right? you know, of kind of religious significance, but we picked an arbitrary 0 point, and then we just say, okay, well, this is how many times, this is how many days have passed since then, okay? And then to kind of just make it a little bit easier, we grouped them into groups of like 365 and a quarter and things like that. So anyway, you can say, well, okay, well, what's this? Unclass this, and then we say, okay, well, what's the mean of unclass X? Okay, well, the average date between these things, and we say, okay, well, and then turn that back into a date. Okay, turn this thing back into a date, and that's how it gives back July 2nd, 2021. Okay, so when you call mean on a date object, right? So here's the X, and when we call mean on X, what it's doing is it's finding this version of the function, right? When we called mean, and it says, oh, you know what, this is a date class object, so we're going to call this version of the function, and then it performs that, and it returns back July 2nd, 2021. Similarly, you have, you know, print, and if you give it a factor object, it's going to look for the print.factor version of the print function, okay? And so this is kind of, this is the reason why, because they're all in this form of the generic function dot the class, this is why they recommend underscores in modern style guides, that you shouldn't use dots in your object names because this can become confusing, right? So for example, when you see a function t.test, there's a function called t, and that will transpose matrices and data frames and stuff like that. There's a function called t, and this almost makes it seem like it's going to transpose an object of type class, of class test, I should say, okay? It's going to try to transpose an object of class test, but that's not actually what this does. This function t.test performs, you know, kind of your stats 10, intro stats t-test, where you're comparing the means of two groups, okay? There's also, you know, we have the data.frame class, and print.data.frame is the print method for data.frame objects, okay? But someone could confuse it if there were to be a print.data method and there was something called a frame class object, and that would be confusing as well, okay? So anyway, use the underscore instead of the dot, like read underscore CSV as underscore Tibble instead. There's a package called prior, and this will load information up, reveal information about whether it's an S3 type or things like that, right? So t.test, which calculates the difference between means, or is used to calculate the p-value for a difference between means, is actually a generic function, meaning that there are versions of the t-test that behave differently for different types of things, all right? So there's the default t-test method, and then there's another version of the t-test for formula type objects, okay? I don't actually know what the stars mean, but there are two versions of t-test, and which t-test function gets used depends on the object being passed to t-test. Are you giving a formula class object, okay? Or are you giving it basically two means or two samples here? And so when you ask for, you know, how is t-test defined, you can tell it's a generic function because in the definition of the function, it says use method, okay, use method, right? And you can, and so anytime you see use method, then it's a generic function, right? If you say, well, okay, well, what's t-test.default? t.test.default, maybe it's not loaded up, I don't know. t.test.default not found. It should be loaded up. Okay, I don't know. Test.formula. Okay, I'm not sure what the things are. Okay. You also have t.dataframe, so you can transpose a data frame, and that is not a generic function. So if you do, you know, what is t.data.frame? That is not a generic function. It's there's actually a function defined, whereas the t all by itself is a generic function. So this is a generic function. T is a generic function. T.dataframe is a specific version of the t function that applies to data frame objects. So it's going to come back and say it's not an S3 generic is false. Is it an S3 method, meaning a specific version of T? That's true. Okay, and these are the different methods of T that exist for this function T. You got T.DataFrame, T.Default, and you got these other versions of T for more exotic data types, that classes that I'm not quite sure of. So for example, here we have X, which is a matrix, and T applied to X will just transpose the matrix, right? So normally X, in this case, X would be, so X looks like this, and you can transpose X, and it looks like that, okay? You can take the same function and apply it to a data frame, right? So here, I'm creating a data frame. The data frame looks like this, and I can transpose the data frame, and I get back this, okay? And the functions behave similarly, which you might not have even realized that these were different functions, but the internal code for each function is different. So the default T function uses a kind of an internal generic that will transpose it, okay? Whereas when you call transpose on a data frame, what it first does is it converts the data frame into a matrix, and then it says next method, which will actually call this, right? So first converts it to a matrix, and then it calls this, which is, you know, it's a subtle difference, but it is a different function. So, so there you have that, okay? You can ask for what are all the methods that exist for a certain function. You can say, what are the methods that exist for mean? And you've got a mean for date objects. You have the default mean function. You've got for different kinds of object types, and you have mean. And then you have different methods that exist for the t-test as well. Another thing you can do is you can take a certain class, like this is class TS for time series types objects. And you can say, what are all the methods that exist for time series objects? And it says, okay, well, here's the subset function. Here's the subset along with the assignment function. There's the aggregate function and the print function and I don't know, whatever, all of these other things, plot and stuff. And these are all just specific versions of the functions that apply to time series class objects. Is that all right? Okay, let me give you your next quiz answer for today. Next quiz answer today is C. C as in cat. C as in cat. Okay, so let's take a look at just defining new classes, okay? Defining a new class in S3 is very simple. You just tell R, hey, this is a new class, okay? So it's an ad hoc, kind of on the fly, no formal definition stuff. You just say, you know what, I just want to set the class to this thing. And so here I'm going to take a list apple, and you can do it with this function called structure. Okay, during creation, you can use structure, which will create something of a certain class. So this is a list with one element apple, the string apple in it. And we're going to say, you know what, this is going to be class fruit. And boom, now we have defined a new class of object called the fruit class, okay? All right, another way you can do it is you can just create the object first. Y is a list containing the element banana. And then after the fact, after you've created it, you can just assign the value fruit to the class of Y, okay? And this also works as far as defining a new thing, right? We could have changed this and been like, the fruit could have been, the class could have been food or something like that, right? And this is just whatever it is, you define new classes this way, okay? So either of these would have defined a new class called fruit. It's very ad hoc, okay? No, just do it, and R is like, all right, here we go, new class, that's fine. All right, and you can just, and then later, you can say, okay, well, what is the class of X, right? So X is this apple that is of class fruit. And we can say, well, what is the class of X? And R goes, yep, it's class fruit. Earlier you defined class fruit, and here it is, okay? And then there's a function, okay, inherits, right? And this is kind of a way of saying, is X a fruit type object? And that's going to return true, right? So you can say, does X inherit from fruit? And again, inherit is kind of the idea of like, if you had a hierarchy of things like the parent-child, so if you have like, so I don't know much about taxonomy, but you could have like a cat. A cat is, you know, belongs to the feline family or something, which also includes like lions and tigers and I don't know, jaguars and stuff. Okay, and those are also belongs to like mammals, and those belong to vertebrates, and those just belong to animals in general, right? The animal kingdom. And so you can say, is a cat a vertebrate? Yes, it inherits from vertebrates. Does cat inherit from mammals? Yes. All right, cat. Because if you ask what's the class of a cat or something, it would actually return a vector. Okay, and so objects can have multiple classes. And so, you know, a cat is a feline, which is a mammal, which is a vertebrate, which is an animal. Okay, and I don't know whatever else, right? There's kingdoms and phylums and whatever orders, stuff like that. Okay, and so that's what we have here. And so here we have a tibble. The diamonds tibble is tibble df, which inherits from tibble, which inherits from data frames. Okay. The factor, an ordered factor, is an ordered factor, which inherits from just factors in general, right? And so if when it searches for a method, it's going to kind of look for a method specific to this. And if it doesn't find it, it'll look for the method specific to this. And if it doesn't find it, it'll look for the method specific to this. And if it doesn't find that, then it will be just a generic method, okay? Or the generic function. And similarly, it'll look for things first for here, and if it doesn't find that, then the next one, and so on and so forth. And you might wonder, well, if I can just do class, you know, why do I have to bother with inherits? Okay, so one thing is that when you do, so what's the difference between inherits versus just class equals the class name? You know, one thing you can do is you can say, is diamonds, does that inherit from factor type? Okay, and this will just return true. Okay, whereas if you ask, what is the class of diamonds, diamonds $cut, is that equal to factor? Remember, this thing returns a vector, and it's going to return ordered then factor, and so you're going to get a vector that says false then true. Okay, and so I mean, you could do an any, you could put this inside of any, and then it would be equivalent, but this is just kind of a more compact form. Does it inherit from this class, this type? All right. This is not required. It's not required when you develop when you define a new class like fruit. You're not required to provide a constructor function, but pretty much everything else in R that is an S3 object type have constructor functions. Okay, and a constructor function is basically a function that we use to kind of create objects of that type. So for example, factors are a type of object in R, and you have a constructor function, a way to create a factor called factor. Okay, data frames are an S3 class object, and you have a way to create data frames by using the function data.frame. Okay, so constructors should have one argument for the base object and one for each attribute, and constructors usually have the same name as the class. Okay, so here we can create a constructor that's going to create objects of the fruit class. Okay, all right, and again, this is not defined, but we can create one, and so this will create this is a constructor function that will create objects of the fruit class, and all it's going to do is it's going to take X in, it's going to check to see if it's a character vector, and if it is, if it's not, it's going to error out. Okay, but if it is a character vector, then it's going to throw that inside a list, and it's going to assign the class to be fruit. Okay, so here we can say make a fruit out of this character string pineapple, and Z will say, okay, here's a list with the object pineapple in it, and its class is fruit, and that's it. Does the object need to be in a list? No, I've just been doing that. Okay, but it doesn't need to be a list. Classes generally are complicated, and so lists offer the flexibility to do stuff that you want to do. Like when you create a linear model, the LM object is actually a list with all sorts of stuff in it. But it doesn't have to be a list. It can just be a matrix. It could be an atomic vector. It can be whatever. And then it comes with a class, okay? Frequently it's lists, but it doesn't have to be a list. Okay, so this is it. This is a way to construct it. So here, LM is technically a constructor function, okay? And it creates objects of the LM data type, or not data type, LM class. And so here we just create a linear model between the MPG and the displacement of an engine from the data set MT cars. And then we throw that into the object LM MT cars, and we say, what is this class? It's class LM. And there's a specific version of the print function of LM, and it prints it out like this, right? And I think you guys are familiar with this if you've taken 102A or 101A. So you've seen, or even if you're in the middle of it, you've seen this printout. This is a special way of printing out LM objects, okay? And it looks like this. And the class of this is LM. Now R is informal, and it says it doesn't matter, right? You can take class and we can just change it. I can say, you know what, I want to turn this object, I want to turn it into a data frame, okay? And all we do is we change the class to data frame. We shouldn't do this. Don't ever do this. But R doesn't check, and R will let you do stuff like this, okay? And then you say, okay, well, print this out. Now it tries to print it the way it would print out a data frame, okay? And it looks at the names in this list, and it tries to print this out, and it gets confused, and it says you've got coefficients, residuals, effects, but there's 0 rows or 0 length row names, and it doesn't print out properly, okay? Did you lose your information? No, you didn't lose it, okay? That information still exists, because if you ask LM empty cars coefficients, it gives you the intercept and the slope and stuff like that. But now the class of LM empty cars is class data frame because we told it so, right? It's like telling, I don't know. It's like taking your dog and saying, okay, you know what? Now you're a cat, and you treat it like a cat, right? I don't know. It's just like, or maybe more jokingly, right? Like like a kid brings in a raccoon from outside and says, "This is my dog," and I want to put a collar on it or something, right? We shouldn't do that, right? So the lack of built-in validation can be problematic, but it rarely causes any issues, okay? And just because you can change the class doesn't mean you should. Actually, you probably never should, but R's not going to protect you from doing silly stuff, okay? So here we can create some methods and generics, all right? So the way we create a generic function is we use this function called useMethod, okay? And what useMethod does is it's going to say, all right, this is a generic function, and it's going to look for functions that kind of carry the same name here, okay? And so here I'm going to create this function called quotation. And what quotation will do is it's going to just return some quote based on the object you give it, okay? So let me just show you some examples here, all right? So this is a brand new function. This doesn't exist in R, but we're going to create a generic function, and it's a generic function because we're using useMethod. That's what makes it a generic function. So here I'm going to do quotation.fruit. Quotation.fruit is going to be, if we give it an object of class fruit, this is going to be what it returns. The function, all it does is it returns a string, okay? It's going to return the string. Fruits are an important part of a balanced diet. So here I'm going to create X again. This time X is a list containing banana, and its class is fruit, okay? So we say, what is the class of X? X is fruit class. And the quotation, and if we say quotation X, R says, there is a quotation. Well, first it says quotation, it calls this function and it says, oh, use method quotation. Use method quotation says, okay, let's look at the class. The class is fruit, and there is a quotation.fruit function, and quotation.fruit function is this, and so it returns fruits are an important part of a balanced diet. Okay. You can define new methods for existing functions. So here, you know, the function mean already exists. It's a generic function as it is. And I can just say mean.fruit. Okay. Now this doesn't make sense at all. Like, what's the mean of a fruit? That doesn't make sense. But we can just say, hey, you know what? Just return the number 5. Okay. Just return the number 5. And so x is still this banana list containing banana of class fruit. And so when it says, what's the mean of x? R says it's 5 because it finds this function mean.fruit. Okay. And again, there's no check. R doesn't care. R doesn't actually check to see, does this even make any sense, right? It just says, oh, okay, mean.fruit. Yeah, there we go, right? We have a question. Do you have to use method to define quotation as a generic function before defining the specifics of quotation.fruit? Okay, well, you could define this without defining this, okay? And R is not going to check, okay? R is not going to check. It's going to just let you define this, okay? And it's not going to return an error. However, if you don't define this, okay, this is not going to work, okay? If you don't define this thing using use method quotation, okay, quotation is not going to work. This function, what this thing does is it links quotation x to this function quotation.fruit. Okay, it links this thing to this thing. Okay, you can define this, and R's like, okay, whatever. But if you don't define this, R doesn't know that when you call this, you're looking for this. I hope that makes sense. Okay, and the way the method dispatch works is R just kind of takes the generic function, which right now is quotation, and it pastes it with a dot and the class. Okay, and it's going to take the class and it's going to paste it there. And so basically what it's going to do is it's going to say, oh, you gave me quotation here. Quotation is this, and it's going to search for quotation.fruit, and it finds quotation.fruit and it returns this. Okay, so it's going to just paste the function name along with the class name, and if it doesn't, and it searches for those things, and if it doesn't find it, then it's going to do dot default. Okay, dot default, and that's just so something falls back on. Okay, so here again, here's my generic function, use method quotation, and then we're going to define quotation.fruit, quotation.apple, quotation.default. Okay, and this is how it works, right? So here, object A is going to be a list that says Fuji, and its class is apple and fruit. Okay, so first, R is going to look for quotation.apple, right? It takes this class and it says quotation.apple. Ah, yes, quotation.apple exists, and it returns an apple a day keeps the doctor away. Here, we've got object B, which is a list containing Chiquita, and its class is banana and fruit. And we say quotation B. Okay, so first it looks for quotation.banana. And it says quotation.banana. I don't see that anywhere. Okay, so it goes to the next one. And it goes, okay, right here. Quotation.fruit. Does that exist? Quotation.fruit exists, and it returns fruits are an important part of a balanced diet. Okay, and here we have object C. This is list Duncan, contain class donut. Okay, and it's going to search for quotation dot, when we call quotation on this, it's going to look for quotation.donut. Doesn't find quotation.donut. It looks for, and there's nothing after that. So then it goes to quotation.default. Quotation.default comes back with let thy food be the medicine and medicine be thy food. Okay. What's the point of the list? There's no point. Okay. It could have just been a thing. I didn't have to use the list here. Most S3 objects are built out of lists though. Okay, and that's why I'm using a list. That, like, I would say most S3 objects are built out of lists, but things are not. Like factors are built out of an integer vector, and it works just fine. But you know, things like data frames, that's built out of a list. Your linear model object, that's built out of a list. Most of your S3 objects that you're interacting with are built out of lists, but it doesn't have to be inside a list. It could have just been an integer or a character vector. Yeah. Okay. So here, B again is class banana and class fruit. And when you call quotation on B, it looks up class quotation.banana, doesn't find it, and so returns quotation.fruit, okay? And it returns this. But you can just say, you know what? I don't care. I want you to use the apple method. You can do quotation.apple, and it's going to use the wrong method, and it will return this, right? So it would be like kind of like if I hand you a hockey puck, and I say shoot it like a gun, you would do your best. You'd look for a trigger on the hockey puck and try to do something, but it doesn't. But you'd just kind of be confused. And similarly, if R can do it, it's going to do it, but it might return a thing. Yeah. Does the order of the class vector matter? Yes, the order of the class vector matters. So if you do class fruit and then banana, it's going to search for the fruit method first, and if it doesn't find fruit, it's going to look for the banana method. Okay. So the order of this vector matters. Okay. Okay. I know I'm over my time here. If I get rid of the default thing, okay, if I get rid of this default and I give it something where this method doesn't exist, right? Quotation.donut does not exist. And if there's no default, then it's going to return an error. Okay, it's going to say no method exists. So if you don't give it a default, then it'll return an error here. Okay. Here's some inheritance stuff. I'm going to kind of skip over this. I'll let you read through it. And then there's also a little bit of a self quiz, and I highly recommend that you take a few minutes to go through this. Okay. And you can just kind of flip through, but let me just show you the first thing, right? So here, f is defined as a generic function. Use method f. I've defined f.j, which is going to take x and add 2. And I've got f.k, which is going to take x and add 10. And here k is 1. So if I call f on k, what is it going to return? It's going to return an error. It's going to return an error because k doesn't have a class. K doesn't have a class. So it's going to try to do the default. It's going to look for a default method. Okay. Well, first it looks for type double, f.default, f.numeric, f.default. None of these things exist. And so it errors out. Okay. This gives you the full details of what it tried to do. Okay. Here, I'm going to assign the class of k. I'm going to assign j to the class of k. And so when I call f on k here, it's going to run f.j. Okay, and it's going to take the value 1 and add 2, and it's going to return 3. Okay, and this is the details. Its first searches for f.j, which it finds, and it returns a 3 here. Okay, and so there's more to the slides here, and so I recommend you just kind of check them out on your own time. All right, sorry for going a few minutes over here, but we'll end here. Let me give you the last quiz answer. Yes, the second quiz answer was C, and the last quiz answer is A. A as in apple. A as in apple. Okay, that's it for today's lesson, and we will see you guys on Wednesday. Have a good night.